This video is on vertical motion in one dimension. Question 1. Adam throws a ball vertically upwards with an initial velocity of 40 meters per second in the absence of air friction. For this problem, let the acceleration due to gravity be 10 meters per second squared down. Complete the table. So we have times from t equals 0 to t equal 8. We need to determine the acceleration of the object, velocity, displacement, and total distance traveled after every second. So velocity, we're going to use this equation. V final equals at plus v initial. Displacement, we're going to use y final equals 1/2 at squared plus v initial t plus y initial. So this is velocity final, acceleration, duration of time, velocity initial. This is final displacement. This is acceleration. This is duration of time. This is initial velocity, duration of time. And this is initial displacement. So the acceleration due to gravity is always going to be 10 meters per second squared down. What does that mean? That means the Earth is always pulling the object down. It's pulling the object down. So when you throw an object up, the Earth pulls it down. At the very top, the Earth pulls it down. When the object is moving down, the Earth pulls it down. So the acceleration is always 10 meters per second squared down. Let's talk about the velocity. When you throw the object up, the velocity is positive 40 meters per second. And the velocity decreases. At the very top, the velocity is 0. And when the object starts going down, the velocity is negative. So I'm letting positive velocity be upwards. Negative velocity is downwards. So you could see using this equation, initially the velocity is plus 40. After 1 second, it's plus 30. After another second, it's plus 20. Then plus 10. Then it's 0. Then it's minus 10. Then it's minus 20. Then it's minus 30. Then it's minus 40. The displacement, we're going to use this equation. This is the total displacement of the object after each second. The moment after we throw it, t equals 0, the displacement is 0. Then after 1 second, the object moves 35 meters up. After 2 seconds, the object moves 60 meters up. Then after 3 seconds, the object moves 75 meters up. Then after 4 seconds, the object moves 80 meters up. You see between times equals 0 and 1, the object moves 35 meters. Then between 1 and 2 seconds, the object moves 60 minus 35, which is only 25 meters. Then between 2 and 3 seconds, the object moves 75 minus 60, which is only 15 meters. Between 3 and 4 seconds, the object moves only 5 meters. 80 minus 75 is 5. After 5 seconds, the object is now going to go from 80 meters up to 75. That means it's going down. Then at 6 seconds, the object is only 60 meters above the surface. After 7 seconds, the object is 35 meters above the surface. And finally, after 8 seconds, you just plug it into the equation, the object is at the surface. So you can see with the displacement, the object goes up, it reaches a maximum of 80 meters, then it starts going down. The total distance traveled, we just add up the total displacement in the beginning. And after time equals 4 seconds, now we have to account for the displacement up and then the displacement down. So in total, the object travels 80 meters up and 80 meters down, which is 160 meters. Question 2, use a pencil and ruler, draw an acceleration versus time graph, a velocity versus time graph, a speed versus time graph, a displacement versus time graph, and a distance versus time graph for the ball. So acceleration is always 10 down, so that's why it's negative, because I said positive points upwards, negative points downwards. The velocity, we start at plus 40th and it goes down, it decreases to 0th, and when it starts moving down, the velocity is negative. The speed, we throw it up, it's 40, 30, 20, 10, 0, and then when it starts going down, the speed increases to 10, 20, 30, 40. Remember, speed is always positive, velocity is a vector, it has a direction also, it could be negative. Displacement could be negative, so when we throw the ball up, the object up, the amount it goes up decreases every second, and at 4 seconds we're at the top, and then the object goes down. The total distance traveled, you could see it increases, and at the very top the slope is 0. Then when it starts going down, the displacement increases again. Sorry, the distance it travels increases again. Definitely memorize these graphs, understand them perfectly. Question 2. Enoch throws a ball vertically upwards with an initial speed of 47 meters per second at an elevation of 88.48 meters above the surface of the earth. What will be the acceleration of the ball at the moment after it's thrown upwards? It's 9.81 meters per second downwards. What's the acceleration of the ball when it reaches its maximum height? That's 9.81 meters per second downwards. Squared, meters per second squared. Part C, what will be the velocity of the ball when it reaches its maximum height? That's 0 meters per second. Part D, how long will it take for the ball to reach its maximum height? V final velocity equals acceleration times change in duration of time times initial velocity. Solve for time, we get a value. Part E, how many meters above the surface of the earth will the ball be when it reaches its maximum height? We use this Suvat equation. V is final velocity, U is initial velocity, S is change in displacement, S is S final minus S initial. Part F, what will be the acceleration of the ball just before it strikes the surface of the earth? It's 9.81 meters per second down. What will be the velocity of the ball when it reaches 89.50 meters above the surface of the earth? We use this equation, final velocity squared minus initial velocity squared equals 2 times acceleration times change in displacement. So S is S final minus S initial. Plug in the numbers, we get a value for V final. Part H, how long will it take for the ball to be 89.50 meters above the surface of the earth? Plug in the values. We could use our GDC, graphic display calculator, or just any calculator, hopefully, if it's scientific, to solve for time. Part I, what will be the velocity of the ball just before it strikes the ground? Plug in for the variables that we know. Solve for velocity final. Part J, what is the total distance the ball travels during the first 4.5 seconds? So from part D, we know that it will take 4.79 seconds to reach its maximum height. So what that means is we don't have to add the ball going upwards plus the ball going downwards. It's just the ball going upwards. So plug in to the Suvat equation and solve for y final. Part K, what is the total distance the ball travels? So it's the ball going up plus the ball going down plus the ball going down from where it was thrown from to 0. So that's why there's a 2 here. Because the ball goes up and down, and then it reaches where it was thrown, and then we have to go from 88.48 meters to 0. Part L, how long will it take for the ball to be 300 meters above the surface of the earth? We're going to use this Suvat equation and solve for t. You could use a calculator. Ask your math or physics teacher if you don't know how to use a calculator to solve for time. Part M, use a pencil and ruler, draw a displacement versus time graph, a velocity versus time graph, and an acceleration versus time graph for the ball. So this is what a displacement versus time graph would look like. It was thrown up initially. That's why the slope is positive in the beginning. You see the velocity versus time graph, it was thrown up initially, so it's positive. And at the very top, the velocity is 0, then it goes down, velocity is negative. Speed is always positive. So when it's thrown up, it slows down, then it reaches the top, the speed is 0, then when it goes down, the speed increases again. Acceleration is 9.81 meters per second down. 9.81 meters per second squared. Question 3. Noah drops the ball from rest at an elevation 830 meters above the surface of the earth. What will be the acceleration of the ball at the moment it is dropped? It's always 9.81 meters per second squared down if there's no air resistance. Part B, what will be the acceleration of the ball when it is 415 meters above the surface of the earth? 9.81 meters per second down, squared, down. Part C, what will be the acceleration of the ball just before it strikes the surface of the earth? 9.81 meters over second squared down. The earth is always pulling it down, pulling it down, pulling it down. Part D, how long will it take for the ball to be 415 meters above the surface of the earth? So let's just say where the ball is dropped, that's y equals 0, and positive y points down. So where the ball is dropped, y initial is 0, y final is 415 meters. It's dropped from rest, so v initial is 0. Solve for time. Takes 9.20 seconds to reach 415 meters above the surface of the earth. Part E, what will be the velocity of the ball 415 meters above the surface of the earth? We're going to use this equation. V is final velocity, U is initial velocity. A is acceleration, S is change in displacement, which is S final minus S initial. Plug in for the variables we know, solve for V final. Part F, what will be the velocity of the ball just before it strikes the ground? So Y final is 830, Y initial is 0. Part G, what is the total distance the ball travels during the first 8 seconds? Let the location of where the ball is dropped be the origin. Let positive y-axis point down. This will eliminate the negative signs. So we plug in to this equation for all the variables we know. Solve for y final. Part H, how long will it take for the ball to be 300 meters above the surface of the Earth? So for 300 meters above the surface of the Earth, y final is 530. Y initial is 0. Because I'm saying where I drop it, y initial is 0. That's the origin. Solve for time. Part I, what is the average speed of the ball? Average speed is total distance traveled divided by total time taken. So total time taken is 13 seconds, approximately. So average speed is about 63.9 meters per second. So this is always important. Draw a displacement versus time graph, a velocity versus time graph, and an acceleration versus time graph for the ball. So here I'm letting positive y point upwards. If I let it point downwards, Vy would have been a positive slope, and A sub y would have been positive. Question 4. Eber throws a ball vertically downwards with an initial speed of 22 meters per second from a height of 88.48 meters above the surface of the Earth. Part A and B is trying to convince us that the acceleration due to gravity is always 9.81 meters per second squared downwards if there's no air resistance. Part C, what will be the velocity of the ball just before it strikes the surface of the Earth? Once again, let the location of where the ball is dropped be the origin, meaning that's y equals 0. Let the positive y-axis point down. This eliminates all negative signs. So part C asks for the velocity of the ball just before it strikes the surface of the Earth. We're going to use this Suvat equation here. Plug in for what we know. Solve for V final. Question 14, how long will it take for the ball to reach the surface of the Earth? How long? So we want an equation with time. So we're going to use this equation, plug in for what we know, solve for time. So let's use a calculator for this. Part E, what will be the velocity of the ball when it's 4,000 meters above the surface of the Earth? So our original displacement is 0. Our final displacement is 88.48 minus 4,000, which is 48.48. Solve for V final. Part F, how long will it take for the ball to reach 4,000 meters above the surface of the Earth? How long? So we want an equation with time. Part G, what is the total distance the ball travels after 12.5 seconds? So we're going to use this equation here and solve for S final or Y final. Part H, use a pencil and ruler, draw a displacement versus time graph, a velocity versus time graph, and an acceleration versus time graph for the ball. So the ball was thrown downwards. So you could see the acceleration is always 9.81 down. The velocity initially was negative, so that's why the initial velocity is below the origin. And you could see the slope of displacement versus time gives us the velocity, so that's why the slope in the beginning is negative, because that means it was thrown downwards. Question 5. You are standing on the top of a building 135 meters tall. You throw a ball upward with a velocity of 22 meters per second. At the exact same time, a friend throws a second ball upward from the ground with a velocity of 46. These two balls then collide at some later time. Part A, how long after these two balls are released when they collide? So draw an image. Remember, you throw something up, and then at that same moment, someone else throws something up, and then after some time, they both hit each other. Because when you throw something up, it eventually goes down. And then your friend, when he throws something up or she throws something up, that is going up at the same time that your object is going down, your ball. So we're going to have two equations. One equation for the object you throw up, one equation for the object your friend throws up. So this is what I highlighted, what you threw up. This is what your friend threw up. Set them equal to each other and then solve for time. So it takes 5.63 seconds for both objects to hit each other. Part B, where will these two balls be when they collide? Well, you could use any one of the two equations that I just highlighted. So you just plug in your answer for A to solve for part B. Part C, what will be the velocity of each ball just as they collide? So we need to use this equation. Final velocity equals AT plus initial velocity. Some people write it like this, where U is initial velocity. So for the object you throw up, you're going to get this equation. For the object your friend throws up, your friend gets this equation. Part D, what would be the relative velocity between these two balls at the moment they collide? So just take the difference of the two and the magnitude of the difference. Question 6. From the top of a building 85 meters tall, a ball is dropped. At the same time, another ball is thrown upwards from the ground with a speed of 46 meters per second. How long after the balls are released will they hit? So we need two equations, one equation for each ball. Then set them equal to each other, because when you set them equal to each other, that's when their displacement is equal to each other. And that's when they should have the same time. So once you set them equal to each other, you solve for time, you get about 1.85 seconds. How high above the ground will these two balls hit? Take one of the equations and plug in your answer from part A to get part B. Question 7. You are on top of a building 44.2 meters tall. The adjacent building is 98.1 meters tall. You throw the ball upward so that the ball lands on the roof of the adjacent building 4.15 seconds after the ball is thrown. What will be the speed of the ball when it lands on the roof? So we're going to use this equation. It's a Suvat equation. We know S final or Y final is 98.1. We know Y initial is 44.2. They gave us T. So now we could just solve for V initial. 33.3437 meters per second. So now they want the speed of the ball once it lands on the roof. So this is a two-step problem. Step 2, we're going to use this equation. V is final velocity, U is initial velocity equals 2AS. S means S final minus S initial, which is change in displacement. So now we could just solve for V final. The answer is 7.37 meters per second downwards. So now take a break and play this video game. Please share this video game with your physics friends and physics teacher.